Okay, good morning once again, everyone.
Good morning, sir.
Good morning, sir.
Yeah. My name is Felix Labi Aye. I'm the one to take you through the web programming class. Now, there are some few things that I've realized. Most students usually come for the VLE class. They join and they leave. What you probably might not know is the time you join and the time that you leave are all being logged in the VLE. So I advise you stay glued to the VLE during lecture periods, and you make sure, at least, even if you are timed out, you come in again. At the end of the day, I will be able to record a mark for you in terms of the attendance. All right. So I'm not really going to waste much time. From the timetable earlier on, those that just joined, on the timetable, we are supposed to have a class from 10 to 11. I spoke to the examination coordinator to extend it to 12, but unfortunately, it has not reflected in the one that has been posted that has been shared amongst students. So from now on, our lecture for the VLE for web programming will start at 10 and will end at 12, starting today. All right. There are some few things that we would be going through for this particular lecture, and I expect students to be contributing because I will be calling people randomly to ask questions. I expect you to answer, especially when you have done, or you are coming from a course, which is the Introduction to Computer Science. All right. So at the end of this class, the students should be able to design and also implement a professional web application. I'm sure most of you already have an idea. Okay, we're coming to develop a website, we're coming to design a website. So at the end of this, you should be able to know what the designing of a website is and what the development of a website is. So this course is to provide students with the knowledge and the requisite skills of web technologies, which is needed to design, to build, and also to deploy websites. And by deploying websites, the website could be static or it could also be dynamic. As we move along, you'll get to know the difference between a static website and also a dynamic website. So when a website is deployed, we might have the chance to also incorporate some sort of database connection to the site, where we'll be taking in some forms from the user. So for instance, just like your registration process, you probably would be asked to enter your name or your password, or maybe your telephone number, some few things about you, which will be stored in a back-end database situated somewhere, probably on a server. So the topics that we'll be treating would include a client-side technology, which would include HTML5, CSS3, and JavaScript. So that is the front-end aspect of the site, of the web application that you're developing. So when you say a client-side technology, these are the three main technologies that we normally use when we develop client-side application: the CSS3, HTML5, and JavaScript. In fact, there are other types of frameworks that are also available. We would try to go through as many as we can. Now, our advice, you take this particular course very serious. The reason is, unlike the other courses that you might have taken in the departments, for instance, programming with C or programming with C++. I don't know which one you took in first year. You know, most of the things that you were taught were centered on, if it is C, everything that you did was in the area of C. You learn how to declare variables in C, how to conduct loop, how to do some few things with C. The unfortunate thing is, this is a 2-credit-hour course, but there are so many markup languages that we'll be dealing with. So you would have an idea, you should have an idea of what HTML is, what CSS is, what JavaScript is, what PHP is, and sometimes we might also include some kind of frameworks. So it's more or less like you are learning about 5 different markup languages or languages within this particular course. So I advise you take it very serious. So that is about for the client side technologies. For the server side technologies, we will implement PHP, and possibly we might introduce a little bootstrap framework within this to make things so easier for us. And at the back end, we would do some sort of database management by using MySQL. Of course, there are other database software that are available like MongoDB, Access, Microsoft SQL Server, MS SQL. They are all database backend that we can use for development of sites. But this course is solely centered on the use of PHP and MySQL to create a web application. Now, as we move along, I'll tell you some few things, some of the software that we'll be using in the development process of some of these applications. So generally, at the end of this, a student should be able to alter a web page using HTML. You should also be able to make some sort of stylistic decision with CSS. Well, we have HTML here and CSS here, but I was talking about HTML5 and CSS3. These are old versions of the 5 and the 3, but you will have to have a general idea of what HTML is and what CSS is. We'll move along with it. So we'll move at a very top speed. So you should be able to create an interactive website. I'll say we'll talk about JavaScript, jQuery. Maybe that will be a latter part where we'll do the introduction. And we will use PHP for the client side, as I've talked about. And there is one more thing that I would want you to do. At the end of this week, every student should at least be able to design a website using the WordPress framework. And that is an easy way to develop and to design a website. I incorporated this one to make it easier for students that would want to take up some part-time job in the development of websites or in the design of websites to make things easier. So in that case, at the end of this week, in fact, I'm going to do some sort of inspection, I think next week Friday during a practical session, which is from 8 to 12. Students would individually come to my office to display what they have done. I'll explain further as we move on. All right, so the main course outline is what is outlined in here. So students will introduce students to various web technologies and the framework which has both the front and the back end. The front end is what we see in the browser. The back end is what resides behind the scene that we are calling onto. Like if you're looking for information with Google, you type what is maybe web development. The interface that you see is the front end. Behind the scene, fetching the information, the script that fetches the information behind the screen and display on the page is what we call the back end. So students will be able to gain the requisite web designing and programming skills for web development. And it will also make students aware of some ethical and copyright issues which needs to be dealt with when dropping websites. There are a few things that you have to always consider whenever you come out to develop a site or a web application to prevent people from hacking. Now, as I talked about, so for the chapter objectives, I'm going to introduce to you what web development is and some few things, how the internet works and some few other things. All right, so the course presentation, these ones you are already aware, but I will still reiterate for those that are not aware to have an idea of it. So we will have lectures. Those that are trying to using your phone to write on the screen, please desist from that. So we'll have, let me see if I can turn it off. All right. So we have, there will be lectures like what is going on here. There will be tutorials where you will be at the lab. There will be a practical or programming labs. And there is also going to be some sort of activities which will be supported with a handout. I'll give you the handouts for the course, and everything that you are looking out for will be in the VLE. So talking about the VLE, I quickly would want to go through this with you so you have an idea what I mean. Now, this is the dashboard of the website of the course. I'm sure all of you have been able to go through that. So any general information that I deem necessary, I will be putting it in here. So I would want you to pay attention to this side. Now, we have the social forum where I expect you to put in any question at the end of maybe a lecture. Any of your students who answers your question will earn some sort of a mark. So please, our advice, you go through that. Now, the resources that we're going to use for the course is what is located in here. In fact, the whole of W3 School, the whole of this website, let me go there. Yes. The things, those that are relevant to our course, I've downloaded all of them and put the whole of this. I've downloaded everything together with PHP, JavaScript, CSS, and they have been put in here, over here, offline resource for W3 schools. In fact, most of the things that you'll be doing, you'll be using some quotes or snippets from this particular website. So please, our advice, you get this downloaded on your computer as and when you can visit it to enhance some of the things that we do here during your practicals. Okay, so we have a practical, we'll have programming labs, as I've told you about being supported, giving you handouts and PDFs and all. Those ones have been stated. So now, the lectures, as I told you, will start at 10, end at 12, the VLE, and on Fridays, what the class rep discussed with me, we are supposed to have two groups, Group A and Group B. So Group A is supposed to come from 8 to 10 and 12, 10 to 12, Group B. I don't know, but if all of you are able to, I don't know if the classroom will be able to fit. Maybe Friday will determine that. Personally, I would have loved to have all of you within the session because this web development involves a whole lot.
Hello, sir.
Yes.
Sir, please, the CL one, we all can go there.
All of you can go there.
Yes, sir.
All right. So on Friday, from 8 to 12, I would advise all of you come with your laptops. Do you all have laptops? Hello?
Yes, sir.
Do you all have laptops?
Yes, sir.
Great. I was just going to put in a poll for you to answer, but if you say all of you do have laptops, I think that's a wonderful thing. All right, so let's quickly move on to. All right. So please pay attention to this site. So you download this one. Now you can see this is last semester's exam. I'm going to edit it along the line. So I just want you to have an idea of what the exam will be. I've hidden it for now. I think it's hidden from students. The first assignment is what I have in here. I'll change the date, maybe do some few addition, and we'll load it for you. Now, I told you we're going to talk about a content management website, which is a CMS. So it's a framework that helps you develop a website as quickly as possible. So if a client needs a website, maybe tomorrow, you should be able to use a content management website like WordPress or Joomla or Drupal or Kick. There are a whole lot of content management websites that are available. You should be able to use any of them to come out with a website for this client to see probably the following day. So the idea is to use this week to do that. Those that would want to go through some practicals, I have, I think this is a practical course that is online on YouTube. I've always been giving it to students to read. But of course, on Friday, the TA, I'll introduce the TA to you. The TA will be there to run you through what WordPress is and how to develop websites using WordPress. So please stay tuned and get yourself ready when you are coming on Friday. All right, so this lecture, as you can see, we have the Zoom. I have these lectures and the assignments that I have already given an assignment here. So I would want you to go through it. All these sites, I'm going to hide it for you to see what is going on. I have a YouTube channel where I put in some videos of most of the lectures that I hold. Our advice, you visit that if you will not even subscribe, at least once in a while, visit it. And anytime I put up any information regarding the courses that we'll be treating here, you always will have a first-hand information of what I've uploaded. Please do subscribe if you get a chance. But of course, I still would put those contents in here and when they need otherwise. Yes.
Sir.
Yes.
Sir, please, what's the name of the YouTube channel?
Yes, you will see it's FLI. So don't worry, I'll put it up online again for you to see. When I load the video, you will even see it. All right, so let's quickly go through the other ones. So all assignments will be uploaded on the VLE. Any assignment that I give you will be on the VLE. The ones that you are supposed to present, like next week, Friday, you will be in my office individually within the hours of 8 and 12 to submit what you have done. So I advise you take up right now, those that don't have companies, have a company in mind or have something that you think you are very good at. Try to create a website using WordPress for that. When you finish the practicals on Friday, you should be able to go through that and come out with your own website and submit it on Friday for me to mark. All right, so moving on to the next one. So quickly, we have, as I said, the lectures will be very interactive. I'll be asking questions along the line. There'll be labs and all of that. Let me go on to the next one. So if you need help, this is my email address. My office is in Expert Building, room 5, and this is my WhatsApp line. And you can call me also on this phone. If it is after 6, let's say after 7, please don't call me. Let me enjoy my wife. If you think you really would want to talk to me, send me a WhatsApp. I'll respond to it. If you send me a WhatsApp and I'm on campus, I'll let you meet me. Apart from the class rep who can call me up to 9 p.m., no students to call me within the hours of 7 and 9. Please don't do that in the evening. So these are other handles that that you can also get in touch with me. So we have, these are my research areas. So I like web, wireless, and also wired network security, web application, internet stuff. So I put up this so that it will get students ready, those that would want to probably choose me as their supervisor in the final year. You have an idea the areas that I work in. So before you come, you know, okay, this is the area that I want to go into, and he's in this area. So I would want to join. Mr. Obu, there is a TA who is in the department. He's called Emmanuel Obu. I don't know if any of you know him. If you don't, always ask of him. It's Emmanuel Obu. He's one of the, but I think amongst his class, he was the second best or so. You can get in touch with him. He will be my TA for this course and the computer graphics. All right. Attendance, participation, discipline, they are all 10 marks, you know. Individual presentation. So we have a continuous assessment 30, which is 30 marks. And within that, we have a presentation where you do an individual presentation. That is what I talked to you about, starting from next week. We have a group project. I'll give a project with the topics that every student, the group will present at the end of this course. There are some few things that you do, and you present it together as a group for marks. There will be quizzes. I'll have some lab practical quizzes. I'll have MCQ quizzes too as well. And for the end of exams, you can see I have MCQ tentative. In fact, what I have in here, the marks, the total marks, they are all tentative. I will choose within the semester. I will know whether to change it or to maintain what we have. So have that in mind. Please try and come to class early. Right now, we have just 50 students online, meaning there are some students who are not here. Of course, if I do come online on VLE, of course, it means you'll be losing that. All right, so for web project topics, the first one, every student is supposed to pick up a company, or it could be your personal company. It could be a company that maybe your father has a company, doesn't have a website, or maybe a lecturer doesn't have a website. You want to develop a website for the lecturer. Scout round, look for information, and now come out with a WordPress. So this is the first project that you'll be doing. Now, this is what I talked to you about. And this is also tentative, it's not a final one. So these are the topics that the groups will be working on. I have a CRUD application. By CRUD, I mean to say, others will say CRUD. CRUD, meaning your application should be able to create, create some fields. You should be able to retrieve, you should be able to update records, and we should be able to delete records. So any of these projects at the end of the day should be able to do some of these, at least these 4 things. If you come out with, if it's a contents directory for maybe UMass staff, you should be able to allow a new UMass staff to create content for himself by creating his username and password, or maybe picking up some information, which department he is and all of that. Admin should be able to retrieve an information by searching. If it is IR he's searching for, the admin should be able to search IR, and all the IRs in the system should come. If the IR spelling is wrong, he should be able to update the spelling. He should be able to delete a record if the person is no more in the institution. In fact, all web application or all software, most of the software that are available have this functionality, the CRUD process, like creation, retrieval, update, and also delete. So these are the tentative topics that the groups will be working on. All right, you can start working on it maybe from now. You should be able to develop a professional web application. So most of the topics, as I told you, by Friday, the final topics will come. That is probably next week. I'll give it to the class reps. So your project should include, that is for the WordPress that we'll talk of on Friday. Please don't use it to develop any of the project topics that I've given to you for the group. Don't use any content management system for that. All right. Cheating, of course, is not the best of things. I don't like cheating. If I catch you cheating, I'll fail you. And I'm repeating, I'll fail you. The assignments or the exercise that I've given you, if you cheat, I'll see, and I'll give you a 0 for that mark. Please don't cheat. You can still talk to your classmates if you need some help. At the end of the day, whenever you type any code that you present, should be your code, not from your friends. And make sure you submit the code yourself. Do everything yourself. Now, for the software requirement, these are the software that we're going to use for this program, web development. We'll be using Visual Studio and Visual Studio Code. Before, previous students were using brackets, but unfortunately, as at September 1st, 2021, Adobe abolished the the continuation of brackets. And now what they did was they teamed up with Microsoft and migrated all their brackets information from all their brackets, staff libraries, and the rest packages to Visual Studio Code. So the code that you'll be using is Visual Code. So please pay attention to that. And this is the software that you are supposed to download. That is the ID, the development environment that you'll be using. Notepad++ is also accepted. Deprecated bracket is also accepted, but of course, I advise you use this one. XAMPP, which is going to be the web server. I have all those ones within the VLE. I've downloaded them. I've put it online. Let me show you those that won't. Let me see. I have XAMPP WAMP, all those ones. Yes, when you go to the practicals, when you go to software, within that, I have all those software. You can see I have WordPress, I have XAMPP, I have WAMP. Then I'm going to include the Visual Studio Code. And of course, students can also go online and download it. It's free. The XAMPP is going to be the web server, which is going to serve our PHP codes. Don't worry, you'll get to understand all of these. MySQL, XAMPP contains MySQL. XAMPP stands for the X, meaning it's a cross-platform. You can have it installed on Linux. You can have it installed on Windows. AMP is for Apache. M is for MySQL. P is for Perl. The other one is for PHP. In fact, when you have this installed, all these are integrated for you. There are other variants of AMPs. We have WAMP. WAMP is used for, it's normally installed on Windows. So the W for WAMP means Windows. We have LAMP as well, those that are using Linux operating system. I know the class rep is using that. So you would install LAMP, LAMPP. So that one is for Linux. And those that are using MacBook, please install MAMP. In a part of the world, in our parts, Windows, Triumph or the other operating system. So that is why I'm using this. So you can either install XAMPP on Windows or WAMP on Windows. Any of them would work. And now when you are doing that installation, please make sure you have Skype turned off. The ports that WAMP would use most of the time is being used by Skype as well and some other applications. Class rep, have you installed any software for database?
No, sir.
Good. So I would be very happy if all of you do the installation as quickly as possible before you install any software for database. If not, I will have issues. Some of you would have issues along the line. Okay. And those that would want to also virtualize their computer and use maybe a virtualization application like the Hyper-V or maybe VirtualBox or VMware to do the development, that is also fine. All right, so these are the basic requirements of browsers that you will need to run most of the scripts that we would come out with. Okay. So now I'm going to call somebody. Yes. Let's start with today's activity, the internet. From your introduction to computer science and engineering, you have an idea what the internet is. People have started dropping. I'll catch all of you. So quickly, can we have Wisdom, Apuziga? Can you tell us something that you know of the internet? What is the internet? Wisdom, can we hear you? And again, our advice, anytime you come online through Zoom, make sure you change your name. Since I'll be recording the marks for attendance, make sure your name is changed. So I'll be able to record them. Yes, where's Wilson, Apuziga, where are you? Fast. This time I need
Yeah.
yeah.
Yeah, sir.
Yes, Wilson.
Hello, sir. Can you hear me, sir?
Everyone can hear you, Wilson.
Okay. The internet. The internet is made up of a global network of billions of people that are connected via the computer users.
Hey, what did you just say?
I'm saying that.
Yes.
Hello, sir.
Yes, I'm all ears.
I'm saying internet is a global network of billions of computer users.
But you said the billions of people. That was what you said earlier.
Yeah, people connected via computers.
Okay. Does any of you have any other definition for that? Anne and Xavier, are you husband and wife?
Hello.
Anne and Xavier, is that your name? Do you have end in your name?
So I'm Anne and I'm joining with Xavier.
Let me see your face. Yes. When I ask the question, I would want to see you. I want to know you. You are seeing me, so let me also see you. Yes, quick. Anne.
Yes, sir.
Yes.
The internet is a collection of computer networks.
Collection of computer networks. Okay, for now, I think I will take it like that. All right, so quickly, let's go into what it is. So when we have computers that are networked or interconnected, it's at the end of the day will come out as an internet. So would we say a series of tubes like YouTube, tunes to tube, VersaTube, TeacherTube, all these are internet. And how many internets do you think exist? Will you also say Google is one of them? Can we say Google is an internet? Augustina. Augustina and Chroma. Is Google an internet? If yes, what makes it an internet? If no,
hello, sir.
Is Google an internet? If yes, why is it an internet? If no, why is it not?
No, sir.
Okay, Silas, that is your question?
Sir, Google is not an internet. It's a search.
I can see you.
Hello, sir.
Hello,
sir.
Where is your face?
Sir, this is my face.
Classroom, do you see her?
Yeah.
My video is not coming.
It's not coming.
Okay, that's fine.
Sir, please, my video is not coming.
It's okay. You continue.
And so I said that Google is not an internet. It's a search engine.
It's a search engine. Apart from it being a search engine, what is it again?
Pardon me, sir.
Apart from it being a search engine, what is it again? Okay, we can also say it's probably a website or web application or something. Now, a collection of computer networks that use protocols to exchange data is what we term as the internet. In fact, this is very important, the protocol the internet uses so many protocols or channels to be able to communicate with computers from different places. So for instance, the internet that we have on campus, we are able to use it to browse websites. We are also able to use it to send emails. We are able to use it to play online games. We are able to use it to remotely connect to computers that are located somewhere in the universe. And the reason is there are certain channels, protocols, or ports that are available. So these protocols are the ones that enable us to speak to the respective application that we want to talk to. All right, so the World Wide Web, which is the www, and the internet, ideally, they are not the same. So when you talk of the web, it is the collection of websites and pages around the world. So when you go to ghanaweb.com, it is a website. And if it's being a website, it means there are other web pages that are available coming together to form a website. So the World Wide Web is a little different from what we term as the internet. But of course, the internet will probably serve as the mother connections to give way for these World Wide Web applications to work on. So in this case, the internet is larger and also it includes other services for emails, for chats, for online games, etc. Whereas with the World Wide Web, most of the time is centered on the web applications or sites that are available. And that contains respective web pages. The internet, as you already know, sometimes also called the net. So it's a worldwide system of computer networks, a network of networks in which a user at anywhere in the world is able to have access or gain some sort of permission to talk to another user using another computer at a different place. Now, for a brief history of the internet, this is, in fact, all these are in the handout that I'm going to put on the VLE for you to read. So behind the scene, this is how the internet really came about. It was somewhere conceived by the Advanced Research Project Agency, which we term as ARPA, A-R-P-A. Some of these abbreviations I would advise you would have them in mind. In MCQs or multiple choice questions, I'm sure I will be asking you what it stands for. So it was conceived by ARPA, which is the US government, somewhere in the 1969, and was first known as the ARPANET. So the original aim was to create a network that would allow users to perform research at their university and also talk to or connect to other researchers in a different institution. So somewhere in the 1960s, they set up the ARPANET, or the Advanced Research Project Agency, which is the US government, were into coming out with research. So they realized that some of the people or the information that they need, or part of the research is being conducted maybe in the University of Mines and Technology, and another part is being conducted in maybe University of Ghana. So they set up this ARPANET to be able to allow the part of research that is being done here in UMass to be accessed by people in the University of Ghana. So it's more like it was more of a collaboration between people in UMass and also in University of Ghana. So in layman terms, that is how the ARPANET actually started. It was mainly because of research. Well, the first ARPANET, which was established between the University of California, Los Angeles, it was established between the University of California and also Stanford Research Institute, somewhere in October 29, 1969. So please, per the previous analogy I gave you, don't tell me ARPANET started with the University of Mines and Technology and the University of Ghana. That is not it. It actually started with the University of California and the Stanford Research Institute. The whole idea was to store and also forward packets. That is where the packet switching is. So it's somewhere in the 1960s. That is how they were able to think through and come out with this. Within that same time, early the 1970s, that is when they started using the internet to be able to send information to different computers around the globe. That is where the email was born in 1971. Then the TCP/IP began somewhere in the 1974 and was more or less invented by Vincent Cerf. Cerf or Cerf, any of them would work. By now, I believe you know what TCP is and what IP is. Somewhere, the Usenet also came to being in the 1979, and somewhere by 1987, the internet included nearly about 30,000 hosts. By host, I mean to say a host on any device which is on a network. So for instance, my phone, if it is on a network, it becomes a host. My computer, once it's on a network, it becomes a host. So any device which is on a network is a host. So if you connect your computer onto the UMAT wireless or network, your computer is termed as a host. All right, so by 1987, we had about 30,000 hosts, which was not that many. Okay, so still on the history. So I talked about these ones. So we have the WW, the World Wide Web, which was created in 1989 to 1991 by Tim Berners-Lee. In fact, most of the HTML codes, the way to talk to the internet using the WW protocol was more or less invented by Tim Berners-Lee. And during his time, the popular browsers that were available were Netscape. I don't know if any of you know of Netscape. 1994, was any of you born in 1994?
No, sir.
Where about?
Yes, sir. Yes, sir.
Hey, who is that?
Sir,
Apuziga,
please, Alonso.
were you born in 1994?
Yes, sir.
Yes, sir. Yes, sir.
Yes,
So
sir.
if I check right now, and you were not, by the date of birth, you were not born in 1994, I'm going to subtract -2 for your attendance.
Okay, no. Yeah, or 10.
So was any of you born in 1994?
Sir, please ask
Yes,
Alonso.
sir.
Who? Kojo Bwedi, can I see your face?
Yes, sir.
Don't worry, you can be bare-chested. I want to see your face. Kojo Bwedi, where are you now?
I'm in one of the classes.
Now, which of the class?
Yes.
Computer science?
MC.
Oh, okay.
Yes.
So how old are you then?
So I'm 24.
1994, you were not born. How were you born?
I wasn't born in 94. It was Alonso who was born in 1990.
Who is Alonso? Where is Alonso? Yeah, so Netscape, well, I chanced on Netscape during my university years. In fact, it's one of the funniest browsers ever. It was, well, at that time, it was good. Yes, so that was when the popular browsers were Netscape and Internet Explorer 1995. Of course, that tells you it came with Windows, not even SP, Windows 98 thereabouts. Yeah, even that's still 95. Old versions of Windows. All right, so somewhere along the line, we also have Amazon also springing up with their products and services. Google somewhere came in January 1996. Wikipedia launched their web application or website to take in records of people somewhere in 2001. MySpace, I don't know if any of you know, MySpace was sometime back the American social network networking service. And it was between, it actually was founded in August 2003. And people really patronized it in 2005 to 2009. In fact, it was the largest social networking site in the world at that time, MySpace, until our own gentleman, Facebook Mark, came out with his Facebook in 2004 that beats that. Well, at that time, the CEO was Tim Van der Hoek for MySpace. And the corporation somewhere as of 2005 was worth about 580 million US dollars. And somewhere in June 2006, Yahoo picked it up. Yahoo, surpassed that, and Google also, made much more than that. Okay. So that is how the Netscape looks like. Yes, so this is how the browser looks like. When you type the address in here, you would see this one, moving, animating in a way. So that is Netscape. All right. So if you are here and none of these logos here, you can't identify any of these ones, then it means you are a baby. You should learn to respect those that at least have an idea of even one of these pictures in here. All right, so that is some of the applications that run on the web. Now for the future of the internet, you can see we have Internet of Things. Somewhere it was projected that by 2020, maybe we probably would concur with that research. It was projected somewhere in 2020 that by 2020, you will have about 4 billion people who will be connected onto the internet. And it looks more like that is true. We are in 2021, and that information is quite, the prediction that was made was quite good. Now, and within that, we'll be able to generate a revenue opportunity of about 4 trillion US dollars, 25 million applications. If you go to Google Apps, or you go to the iPhone users, the Mac Store or whatever, you would, you see a combination of that to tell you we'll have so many apps. People develop apps day in, day out, almost all the time. There are lots of them that are being developed. In fact, we have embedded system. It's also intelligent system also springing up. At this time, we have about 25 million plus and 50 trillion plus of data that has been, accrued over time. So the future of internet, these are some of the things that keep coming up. I think one individual also told me it will get to a time where if you walk out of your house, you can even hold a remote control and press it, and the house would collapse, and you can put it in your pockets and put it wherever you want to be. I hope to see that in future. Let's see how it goes. Yes, so this is the assignment I talked about. So you are to give a brief description of how the internet works. And you should note that you are going to upload this on the VLE. And I've set it up as a 1018 assignment. By 1018, I'm sure you might have heard of plagiarism. So you read on how the internet works. And when you are done, use your own English and write how it works. You can include diagram in it and stuff. That is acceptable. When you load it on, automatically it tells you your similarity reports. If it is above 20, automatically you are getting a 0 for that particular assignment. So please make sure you read online, you get good information before you upload onto the VLE platform. Of course, if you plagiarize any part of your work, the system will see, and you get a 0. And again, don't take your friend's own and produce the same thing for me. All right. So that is a caution for you. So there are some key aspects of the internet that we can also talk about. Subnets are independent. When you talk of subnets, you have a network sub. So that is like a subset. So you have a portion of the network that is being segmented. So you can have so many independent subnets that are available. You can also have computers being dynamically able to join and also leave the network. You realize that those times, I think in UMAT, those times, all the staff were assigned what we call manual IP addresses for their computer. An IP address in this sense is what uniquely identifies a user on a network. So my computer, for instance, has a unique IP address, which is on the network of a university. And that IP address is not being used by anybody on the network. Before, every lecturer was given individual IP. So when you mention my name, FLIA, ICT people know that the IP address that they have manually configured for my computer is probably 20. When you mention somebody's name, like Aholo Joseph, ICT knows that the IP address that they've given Aholo Joseph is maybe 21. So those ones are manually given to individuals to stay on the network. And that helps the individual to be uniquely identified on the network, so that if there are any issue, they are able to trace and know who is doing what at any point in time. The fortunate thing is we have something we call Dynamic Host Control Protocol, which is DHCP. Most of the routers or the devices or the connections or the wireless access points that are online, that are on campus, now ICT will not call you to give you IP address, but these devices automatically assigns what we call the IP address to you. That is a dynamic allocation of IP addresses. So built on open standards, there are certain standards that needs to go through for this to work. Lack of centralized control, mostly. So, you know, when you have some of these, you do a sub networks, you have to find a way to centralize it. If you are putting it in something we call a VLAN, that is a virtual local area network. I'm sure you know what local area networks are. Wide area network, you know what they are. We were taught in Intro to Computer Science and Engineering. So at this point, everyone can use it with simple, common available software. Anybody can use the internet to do any other thing. All right, so again, on the people and organization, there are some key individuals or people that when we talk of the internet, in fact, you should never forget about them. And these are the three main people that you should always have in mind, or you should know about them. The IETF, which is the Internet Engineering Task Force. We have the ICANN. Some of you probably might have heard of ICANN, which is Internet Corporation for Assigned Names and Numbers. We have the World Wide Web Consortium, W3C. Now, each of these individuals or organizations are responsible for some few things when it comes to the internet. When you talk of IETF, they are responsible for the protocols and the standards that every device or every application needs to use to be able to talk to each other. There are certain standards that you should adhere to when you are developing some of these applications. And again, when you talk of ICANN, they decide the top level domain names. By top level domain names, I mean to say, if I say a domain name, an example of a domain name is This is just a minute. Let me just. Sorry. An example of a domain name is google.com is a domain name. Eric.com is a domain name. Faisal Suleiman could be a domain name. Suleiman.com can be a domain name. So ICANN is responsible for managing these top level domain names. And the top level domain names are the ones that have a .com, .net, .org, .edu. These are top level domain names. By top level, it means these are the main ones. And within that, you can have some subdomains, like maybe ble.umass.edu.gh. BLE will be a subdomain of the umass.edu.gh. As you move along, you get to appreciate some of these. Now, the W3C, which is the Worldwide Web Consortium, they are responsible for the standards that exist with web applications or the web that we develop. And these are the logos that you should be looking out for when you think about these people and these organizations. Now, can we have Francis Dakon? Can you unmute yourself, Francis Dakon?
Yes, sir.
Good. Now, when we talk of the OSI model, there were 7 layers of 7 layers or levels that were available. Can you list them for us? Hey, as you
Sir,
know,
please, can you come again?
the OSI model, there are 7 layers. List all of them for us in order.
Okay, sir, please. Physical, data link, network, transport, section, presentation, and application.
Are you looking at something and telling me this?
No, please.
Okay, so now when we talk of the OSI model, in fact, anytime you talk of the internet, this is very key. This is very important. You should have an idea what it is. The OSI model is a reference model that is being used whenever we talk about networking or computers being interconnected together. And with this, the transfer of information from one point to the other needs to go through these 7 layers to be able to, for the other person to actually know exactly what is being said. Now, as he said, we have the physical layer, which you can see over here, the data link, the network layer, the transport layer, session, presentation, and application. Now, of course, I know if you also don't know, there's an acronym to know this, and that is, please do not throw sausage pizza away. So please, that is for the physical. Do not, so do data link, not network, throw transport, sausage session, pizza presentation away. So all our browsers, the browsers that we use, they all fall within, in fact, most of the applications that we use on our computer fall within this particular session. Now, each of these layers are responsible for some few things. I'm not going to ask anyone, but I'm just going to recap on this. So for the physical layer, so just like your computer, before your computer will be able to connect onto the network, you should have something we call the physical device itself, which is the cable that you use to connect to your computer, the network cable. So that falls within the physical layer. So devices such as the Ethernet, the coaxial cable, the fiber optic link, and modems, they all fall under the physical layer. At the data link layer, that is the basic hardware protocol. So at this point, you can still have the Ethernet, you can have the Wi-Fi, and some of these also working in here. But at the data link layer, we are more thinking of the MAC address. That is what we normally think of, the media access control. In fact, that is a physical addressing system. So every computer or every device that has the capability of connecting onto a network or internet has something we call the MAC address. So the MAC address is the media access control address. And that usually is in some codes, I think 16 digits. You have A0 colon B4 something, and they are always uniquely, they are unique to every device that you have. So your wireless card on your phone has a MAC address and it is unique. The few digits or the few numbers of the MAC address tells you the first few tells you the manufacturer of that particular device, which is the wireless card or wireless network card or normal wireless card. And the other ones uniquely identifies the hardware itself, which is the physical address of the wireless card. At the network layer, it's also responsible for IP, which is Internet Protocol. And at this point, it does what is we call switching and also routing. And most of the virtual circuits or most of the virtual things that happens in here. So when you move through, the moment you connect your phone, the phone wireless card to a network, you are automatically assigned an IP address, which I talked about. And the IP address is what is going to uniquely identify your phone on the network so that any other person connected to the network will not take ownership of that IP that has been assigned to you. And with that said, you'll be uniquely identified on the network. And at the transport layer, that is where we have the end-to-end connection. And at this point, we add some sort of reliability to the network to help protect it. And TCP and also UDP usually work in this at this particular side. The session layer establishes and sometimes also manages and terminates connection between all these applications that we have. And the presentation layer, this layer, that is a presentation layer, provides independence from the differences in data representation. So that at this point, encryption and some sort of translation from the application to the network format for it to be understood by the other computer which is connected, which you are probably connecting to, and vice versa. So, and finally, at the side, at the application layer, that is where the implementation of some specific applications or communication software happens, like HTTP, POP3, IMAP, and the rest. So your browser always run at the application layer. So first of all, you have a computer. You want to connect, you want to send me an email from your, let's say your computer. You first of all will have to have a physical card, a physical network card, which should have some sort of signals. At this point, you either connect wirelessly or wiredly. So the wire that you connect or the wireless that is available is where the physical layer picks up. And at that point, you connect the cable or the wireless connection to your network card, which is the MAC address. It connects to it at the data link. Then it moves to the network where an IP is assigned. So my phone, I have a connection. So an IP is given to my phone. Then some end-to-end encryption is given to my phone. And the interhost connection or session ID is being created. And there is a presentation over here for data representation, also encryption. And finally, I can now go to my browser or WhatsApp or any application that uses internet, TikTok or whatever. At this point, all these applications will run at the 7th layer, which is the application layer. So at the browser, I come out, or at the Gmail icon application on your phone, I can now go to Gmail. And at Gmail, what I can do is now create an email at that site, send the email to me, FLI, by sending. So you send, it goes through your network, and it goes onto the internet. And for me to see the email that has been sent, if I'm sitting behind my computer and already connected to my computer, then my browser or my Gmail application on my phone can now receive the email at the 7th layer. So that is it. So at the 7th layer, that is where I get my email. Then these are the other processes that you have to go through. Before you send me the email, you start from here, you go through all these things, passes through the physical layer, goes through my physical layer, comes up again to the application layer for me to see. So that is the vice versa aspect of it. Now, I talked about internet protocol working in hand over here. So IP stands for internet protocol. So it's a simple protocol for data exchange between computers. So before a computer or any computer on the network can talk to another computer, it should have an IP address. And most of the IP addresses are in a 32-bit version. Now, there are two main versions that are available now, currently worldwide. We have the IP version 4, which we term as the Internet Protocol version 4. And we have the IP version 6. The IP version 4, as you can see, is made up of 32 bits. And by 32 bits, when we talk of bits, it's made of what? Zeros and ones. It's a binary. Computer understand any information which are zeros and also ones. We can only understand things that are 0 and 1. Now, the 32 bits is also divided into 4 different octets. When I say octets, that it means you already know from Introduction to Computer Science and Engineering that a character is made up of how many bits? 8 bits. So 8 bits makes up a character. So a combination of the zeros and ones will give us a character. If the character is A, it has to be 8 bits. If the character is 2, it has to be 8 bits. So the 32 bits had been segmented into 4 different octets. So by octet, that is 8 bits. So this is the first octet, as you can see. If I count all these numbers in here, we have 1, 0, 0, 1, 0, up to 1. Counting all of them, this is 4, making 8. So this is the first octet. When it comes to the second one, this is the second octet. This is the third octet. This is the fourth octet. So 8 plus 8, 16 plus 8, 24 plus 8, 32. That is how come we have 32 bits for Internet version 4. However, for version 6, it goes beyond that. It's not zeros and ones. It's more of, I think, it's a 16 bit. So we can have zeros, ones, E, F, G, 16 bits. So we have A, B, C, D, E. So you can have these characters also part of it, and you have a total number that you can see. So with that said, and quickly, I would want to, by default, the computer does not understand 145.10.this 34.3, but it understands it when it is being converted to binary. So when you convert 145 to binary, you will get 1001, 0001, 0001. So now, Lydia, I would want you to convert 255 base 10 to base 2 and let us know the answer. Lydia, say hello and let me know you are available. That's right, is Lydia here? Okay, so we have a minus for Lydia. Lydia, are you here?
Sir, please, he's not around.
Okay, so can we have Eliana, a selfie, I would want you to convert 255 base 10 to base 2 and tell us what the answer is. Eliana, a selfie. Say hello and let me know you can hear me. Whilst you are at it, MFA, I would want you to convert 100 base 10 to base 2 in an octet. So you should have 8 digits or 8 bits. Those are just mentioned names. Just say hello, let me know you heard me. Eliana, MFA?
So
Eliana?
please repeat the question for me.
Convert base 10, 100 in base 10 to base 2. That the computer will understand. Eliana, I would want to hear you say hello, so I know you can hear me. Unless you are sleeping on your bed and just online. Eliana? Eliano, it's Sophie. Where are you? You are not in class, but you are connected online. All right, let me pick up my agenda. Eliana, you're still not saying hello. I would want to hear you. Elizabeth, Jechiwa Abwaji, please pick up Eliana's question. 255 base 10 to binary.
Okay.
Anyone who answers a question, I would want you to send me a message anytime you answer a question. I would want to pick your details down. At the chat side, just send me a chat. Someone asked me the deadline for submission. Someone asked about a pie chart. In fact, any of the IDs that you think you can use to develop for this web programming is fine. I will not restrict you, but the ones I showed you are the advisable ones, the ones I would want you to use. I say it because there are certain packages that maybe I would let you install. It's advisable you use the one I recommend. Olivia, yes, Olivia, you have your hands up.
Please, I have a question.
Yes. Amos?
This is Amos.
Okay, Amos.
Sometimes you see the colon symbol in IP addresses. I have no idea what that means. Yeah.
The colon.
Yeah.
Is it full stop or colon?
Colon.
Those ones are MAC address.
Oh, okay.
Not IP address.
Okay.
They are actually, I think, either 12 or 14 characters. Those are MAC address. They are MAC address of the network cards that you have. If it's your phone, it will tell you the MAC address. Like if you hotspot your phone and you give it to somebody to have access to your phone, it will tell you the person's device name and probably the MAC address of that particular person. Those ones are MAC address, which is the media access control. And the MAC address, in fact, it's very powerful. If on the network, your MAC address is blocked, you would try connecting to the internet, to the network so many times, and it will never have access to the internet. All right, Elizabeth, I can hear. I think you have a question too. You have an answer for me. Yes.
Sir, please. You said I should convert
Yes.
M255 base 10 to base 2.
Yes.
Okay, so and I'm getting 1111.
In fact, I'm not, okay, I'm listening. I'm listening. Yes, I'm listening.
So I'm getting, that is, can you hear me?
I can hear you.
Okay. So I'm getting 111111.
Which one is that? Is it 255 or 100?
255.
Yeah, so how many ones do you have?
8.
Great, that's a very good one. Yeah, so for 255, you have a maximum of 8 ones, making 1 octet. So those that have been working on, you'll see that when the configuration of the IP is given, you are given the IP address itself, and you are given a subnet. And usually you will see 255.255.255.0. That is a subnet. So 255 in this sense is 8 bits of ones, making that particular octet. All right. So that is about it. There was supposed to be another person doing that for 100. Who is that? MFA, yes? MFA, your answer is what? Okay, I can see in the chat. But what you have here is 7 characters. So what do you think we can do to make it correct? Hope you understand what I mean.
Yes, sir.
So in a situation where you have characters less than 8, you put a 0 in front of what you write. So in this case, it becomes 011000100. Are we okay?
Okay.
All right. So 100 from base 10 to base 2, it's 0. Of course, we are talking about IP addresses. So I would expect you to put it in the octets, which is 8 digits. Sorry, 8 bits. You have to always use the right words at the right time. So 8 bits. So this is 7. So you put 0 in front of it, making 011001000. So if you are converting it to base 10, the first 0 will be 10 to the power 8 times 0. Of course, will be what? 0. I hope you get me. All right, so that is about it. So you are correct. That's fine. All right, let's move on to the next one. So that is about the 32 version 4. So at the moment, 2 to the power 32. What is 2 to the power 32? Can anyone tell me? Can anyone tell me what 2 to the power 32 is?
Yes, sir.
Okay, what is it?
Sir, 2 to the power 32 will give you, please can you hear me?
Yes, I can hear you.
2 to the power 32 will give us 4294967296.
That's fine. Edna too has put it up there. That is great. Yes, so that tells you, ideally, there is a limitation for IP version 4. And the limitation is if all of us are given public IPs. By public IPs, I mean to say a public IP is an IP that is available worldwide. So all the computers that we know, all the computers let's say the web service that you know. For instance, let me use it. Let's be here on campus, like the UMass portal or the VLE. The VLE has an IP, which we term as a public IP. If it is a public IP, wherever you are in the world, you should be able to talk to that particular IP. You should be able to connect to that particular IP. So that is what it means by a public IP. Now we have other IPs which we term as private IPs. Private IPs are IPs that are confined within a local area network. So on campus, the IPs that are uniquely assigned to your computers or your phones are what we term as private IPs, because any other person who is not on this particular network, if he wants to talk to your IP, not your internet, if he wants to talk to your IP, he will not be able to talk to your IP because it is a private IP and you are within a local area network. So it's only people within on host computers that are within the local area network and ones that will be able to talk to your particular private IPs. So that is our private IP. So in this case, we have about... Kensmon, do you have a question for me? All right, so
Yes, sir, please.
That's fine. So in this case, we have about 4,294,967. Is it 4 million or 4 million? So that is the amount that we have, the number we have in there. So those are the available public IPs that are that we have in the world. It's actually in billion. So that tells you that, and we are made up of 7 billion people in the world. So if you are 7 billion and assuming everybody is given an individual IPs, after 4 billion, the 3 billion, we have about 3 billion left. So if even babies are using IPs, public IPs, then there is a constraint. We will have an issue with babies, some people not being able to have access to the internet. And that is a limitation of the IP version 4. When the IP version 6, it goes beyond this number. I would want you to research and look out for the total number of hosts. That's the IP version 4, sorry, that the IP version 4, version 6 is able to hold. So I would want you to check that one out. That is something I would want you to research in. All right, but there are more things to talk about. So in the meantime, let me just move on to the others. So that is about the internet protocol. So anytime we talk about TCP, we always talk about IP. So TCP is a transmission control protocol. And what it does is it adds some sort of multiplexing. By multiplexing, there's a situation where we can have multiple programs and some other services which will share the same internet. So you can have maybe your browser browsing on port 80, and you can have an email using a port, an email application like Tenderbird or Outlook or any other Scroll Mail or Hot, any of these email applications sharing the internet with us. But once they are passing through different ports, we are able to multiplex. So that is one advantage of the TCP IP. It is responsible for multiplexing. So in that case, we have multiple programs using the same IPs at a go. So you can have your browser open, you can have Skype open, you can have WhatsApp open. All these applications use different ports to talk to the internet. So that is what makes the internet so great. And I remember I spoke about a protocol being very important whenever you talk about internet. Now, what do we mean by ports? So anytime you talk of TCP, you should have this in mind, ports. So if this whole building, if UMass is a building, okay, if there is a big building like the administration block, is the internet. We have something we call ports. The port is the key that you use to enter your room or your office. So they can have so many ports. So we can have port 80, which runs on web server So if I want to talk to go to my office, I need to use my key, which is labeled probably 80. So that is the only thing that can open my office for me to enter. If it is my office is called email, I need to have a port of 25 to be able to open that. So the internet is the big building, which is the central administration, and we have individual offices within each of them, and each of them have been assigned what we call a port, and the ports are more or less like the key that we use to connect to it. So a port is a number given to each program or service. So you can have just one IP address, one public IP address, like the IP address of the VLE. I can now talk to the VLE because I'm using the browser. I talk to the VLE using ports, either port 80 or port 443, which is the secured SSL, secure circuit layer. I can still use the same IP of the VLE and use a different port, like port 389, which is a port number for talking to maybe remote desktop. If I want to remote desktop into the VLE server, I will just open Windows Remote and type the IP of the IP address of the VLE. So like this, let me just give you an, hey, you people, I hope you will not bombard me with things. So for instance, I don't know if you can see, if I want to go into the VLE server, this is the FOE VLE server, I can either, I'll explain these to you. I can either go through, if this is the port for VLE, if it is the IP for VLE, when I type this IP in the browser, it will work. If I want to go straight using this remote desktop, I can just type in this IP address or like this one, foe.vle or whatever, and I can directly, remote desktop is an application that uses a different port. It doesn't use port 80 or 443. So in this case, I can still talk to it, but this time around, when I connect using the right tool, I'll be able to go into the VLE server. Don't worry, I've already installed put in the username and password, so you will not have access to it. Yes, I should be able to connect remotely to the VLE server. I don't know why it's taking a little longer. Let me just see if I can go to the VLE instead of the FOE. All right, so these are ways to talk to the internet. Although it's the same internet I'm using, depending on the type of ports and the application I'm using, I'm able to go to different places using the same IP address. All right, so port 25 is email, port 222 is for SSH. Okay, I don't know why it's not coming up. But ideally, I should be able to go straight to that particular server, and you'll see a new operating system open, which is the Windows 2019. So in that case, I don't need to walk to the server room to get connected to the server physically. I can just be wherever I am to connect to it. So there's always freedom for reliability, so you don't need to worry about anything. Now, there are other programs that use more simpler protocols like the UDP and instead of the TCP. Now, for UDP, who can give me an example of an application that uses UDP? Anyone? Anyone? Have you realized when you are watching those that have multi-TV or those that have DSTV, you realize that there are times when it is raining, there's a scramble in the network. So you are watching somebody, or you're watching somebody and a portion of there's a glitch in the application, in the video that you're watching, or you call somebody on WhatsApp and you realize that you can hear the person talking and maybe the person's eye within a split of a second is vanished and it will come back. You know, the eye can vanish but still there is a connection going on. And at one point, I'm sure maybe even talking to you, there might be a glitch happening, and you might not see maybe part of my face, or my face will go briefly and come back again. So there are some type of protocols that are unreliable, but it's also good. An example is the UDP, that is User Datagram Protocol. And it's also just like the TCP, which is Transmission Control Protocol. With a UDP, it is not reliable, but it is very fast. You don't need to, the user does not need to, or the system does not need to acknowledge receipt of the information. If the packet drops along the line, it is not so important. It can leave. We don't really concern much about packet drops when we talk of UDP. But when you talk of TCP, it is very important. If you are sending an information over the internet and the packet drops, the information needs to be sent all over again. So that is about the TCP. So moving on to the next one, I think I want to finish this before the next lecture. Let's go on. So we have web servers. Now you should have in mind that a web server is a software. It could be a software, it could also be a hardware that uses the hypertext transfer protocol, which is HTTP, and sometimes other protocols to respond to clients' requests, which are made all over the world. So in this case, the main job of a web server is to display website content through storing, processing, retrieving web pages to the user. And these are some applications that are available. You remember when I said XAMPP, I said the X stands for it being cross-platform. If it is Windows, WAMP. The A stands for Apache. So in our case, when we have the XAMPP software installed, we have the Apache software also installed. It has all these ones installed and also configured for us. Ideally, what you can also do is, for the purposes of this exercise or this class, you can also install Apache alone. You can go to Apache and friends.com and download Apache and install. When it comes to PHP, you can, when it comes to MySQL, you can install MySQL too. When it comes to Perl, PHP, you can also install all these. But XAMPP integrates all these together and helps you install it. If you do them, if they do the installation one at a time, at the end of the day, you might have to reconfigure each of them for Apache to talk to PHP and for PHP to talk to MySQL and all of that. And the good thing is XAMPP or WAMP or LAMP or MAMP or AMPS, I use AMPS, but I would prefer you use XAMPP because AMPS is a little advanced than any of these. Any of these web servers does the installation and configures everything for us at a go. So it's always advisable you use XAMPP. Now, Microsoft, like the system we have, we use Microsoft's Internet Service, Information Service, and Microsoft also has its application that serves web pages, and that is what has been used for the student portal. What we use for the VLA is the XAMPP or AMP or WAMP. That is Apache. That is what we use for the VLE. For the services for the portal, we use the IIS. And it's a product for Microsoft. In fact, when you have Microsoft installed on your computer, we can just activate that particular session so that we can have a web server configured on our computer for us to use. Yes, but for the purposes of this class, we are not using IIS. IIS, most of the time, you use it with C#, Microsoft products, and Microsoft stuff. All right, so that is about web servers. So anytime you think of web servers, you should be mindful that it can be a software and it can be a hardware. If it is a hardware, that is the device itself that the software also runs on it. And the web server, what it does is it listens to web pages. Any request that you make, the web server is responsible for producing the answers or solutions to the requests that you make on the server. So that is an example of a web server. So if those that have the opportunity or that have gotten the opportunity to go to the ICT unit, you will see something like this. This is a rack. The device that houses the servers is what we call a rack. And usually it is a 42U, that is 42 unit rack, where you have the switches, the patch panels, the individual servers. This is an example of the server. There's a server. It could be an Oracle server. It could be in any of the server. Once you have, there's a hardware. And you should be mindful that anytime you buy a server from maybe a company, it doesn't come with an installation. You have to install some of the softwares yourself, like Windows Server and all of the rest. So these are examples. So there's a server, and within it we can have Apache installed to serve as a web server. So that is an example. So application servers. Yes, Olivia or Silas. So I can see one of you have your hands up. Yes.
Okay. So please, is a server a hardware or software?
And that is what I talked about. If you talk, it depends on the angle you are coming from. If it's ideally, a server is supposed to be one robust, either a hardware device that has enough resources to be able to serve so many people that connects to it. Now you need a software on the hardware to make it more of a server. And that software is what serves people connecting to it. Like Facebook, there is a server, which is a hardware. Within it, there is a software that is able to handle all the requests that come from users. Are we okay? So at one point, you could say a server is a hardware. At one point, you could say it's a software, depending on the angle you are coming from. Now, application server software framework that provides an environment where application can run. So you can have the Apache. These are examples of application servers. And I'm taking can we have your line drop?
Yes, sir.
A web server serves pages for viewing in a web browser, while application server provides methods that client's application will call to. And in this case, there is a little more precise. You can also say that a web server exclusively handles HTTP requests, whereas an application server serves business logics to application programs through a number of protocols. Most of these have been outlined also in here. Now, you already know what browsers are. When you say a browser, you know that it fetches for information. A browser, there are lots of them, Microsoft, Mozilla, Firefox. I think I have some in here which have not even been mentioned so far. We have Internet Explorer, Apple Safari. We have the Google Chrome Opera. For the purposes of this, I would always advise you use Google Chrome for your testing. And now, when it works in Google Chrome, you try to make sure your application that you develop is also compatible in any, at least two of these, Mozilla Firefox or Microsoft Internet Explorer. If it is compatible with these ones, then I think you are okay. If you recall, the first time that you use, no, you were not in school then. That was last year. So let me just stop here. Now, we also have what we call the DNS. The DNS is the domain name server. What happens is whenever you connect some sort of connection, but you cannot download a web page, then it means there is a possibility that the DNS server is probably off. Now, the DNS is, I will explain all these things in the practicals. You realize that before you can even get a website, you have to get a domain name. And the domain name will need to be pointed to something we call the DNS server. I'll explain all those things, so don't really worry. Now, when you say a domain name, it's a domain name, set of servers that map written names to IP addresses. Now, Emmanuel Buama, can you unmute yourself?
Yes, sir.
Who is your best friend in class?
Kobe.
Kobe. All right. What is his full name?
Yeah, boy, Evans.
Kobe Yeboah Evans. Okay, so Yeboah Evans. So Emmanuel, can you tell me Kobe's phone number? Just don't look on your phone. Can you tell me?
No, sir, please.
He's your best friend, right?
Yes, sir.
Yes. So this is the analogy I want to put across. Now, it is very easy to remember names than numbers. And the reason is, it is very easy to remember names than numbers. You know, I intentionally asked Emmanuel Boama, his best friend, he said it's Yeboah something. And unfortunately, he doesn't even know his phone number, but he knows his full name. So in the same vein, when we talk of domain names, every domain name that you see, like umass.edu.gh or ghanaweb.com, you see how easy it is for me to mention these websites. Facebook.com, it is very easy to mention Facebook.com. Google.com. Now, if I tell you to tell me the IP address, which is a number that is tagged to google.com, wahala, it becomes trouble. It's difficult because it's always difficult to remember numbers. So now what the domain name server does is, may I know who that is? So what the domain name does is, it makes sure that the names that we know, like google.com, is tagged with the right IP address. So ideally, let me show you something. Just bear with me just a few minutes before we go. When I come here and I type, let's say, umass.edu.gh, sorry. Can you see, please? When I type umass.edu.gh, you can see an IP address has been given here. Now, when I come to the website, when I use my browser, and I come here, and I type this IP address here, let's see where the IP address will go. Okay, let me use a different one. There is a reason for this one because of security issues. Let me give a different one. Let's say, I'm thinking VLA.sumas. You see, this is VL, this is a domain name. Right. It is giving me an IP address of this one. So now let me copy this IP address, come to my browser and paste it here. And let's see what it displays. Does this look familiar to you? Does it look familiar to anyone here? Does this page look familiar to anyone here, please?
Yes, sir.
Yes, sir.
Great. So this is what I want to say. If I come again and I just type VLE.edu.gh, it's also displaying the same thing. So why is that so? It means that the names that is easy to remember are always tagged with something we call an IP address. So you don't, sometimes if you know the IP address, you just go straight to it and you'll be able to talk to it. If you don't know, and you know the name of the address, then you need what we call the domain name server to resolve or to convert the IP address, this particular IP address, or this particular domain to the IP address that is understood by the computer. The computer understands numbers in zeros and ones, and this one is in digits. It's in digits, so we convert it to binary. So when it's converted to binary, if this is converted to binary, then it becomes easier to understand. So that is how it works. So the main importance of the domain name server is to resolve the IP addresses of the domain names that we have. So if you have a domain name, it resolves it to the IP, and the IP is now shown to us. So it makes it very easy without us having to always remember these numbers. Now, the good thing is most of the systems that we have maintain a local cache of the host file. And for Windows, it is located here. For those that are using Mac, you'll see it here. And those that are using Linux, you'll see your host file in here. And please give me just a few minutes. I want to finish this. We have just few slides. So uniform resource locator, that is the URL. This is how it looks like. So in this case, if I want to open this one, it means upon entering the URL in the browser, the first thing is it asks the DNS server for the IP address of uma.edu.gh. Then it connects to the IP address at a port which is 0, port 80, mainly because it is the internet. It is using the browser. And it asks to get CE because CE is here, and it opens this particular file. And at the end of the day, it will display resulting page on the screen for us to see, which we just saw. So the hypertext protocol, transport protocol, as you can see, these are some few commands that HTTP always use. To get the file, by its downloads, to post file, it sends web form response, and to put file, it uploads file. So yes, so for exercise, I would want you to simulate a web browser with a terminal window. Yes, so that is the ping that I use. Remember, I tried to use the ping to show you something. All right, and again, we have the HTTP error codes. So generally, whenever something goes wrong,
Hello, sir.
Yes?
Sir, please, it's 12.
It's 12. Just give me 2 minutes. I'm done.
Okay, sir.
Just 2 minutes. Pardon me, just 2 minutes. So when something goes wrong, the web server returns something special, some code which looks like this. If this 200 is okay, most of the time what we see is the 404. So whenever you see any of these numbers, these are the explanation that is given. And anytime we start programming, there are certain things that you should look out for. When we want to put in, create some kind of files, these are some of the extensions that we look out for. And finally, for security and internet, these are, unfortunately, that we have a large amount of information about us online, and some hackers can also take advantage and also break into our network and also steal some information. There is an element, this part is what I really wanted to talk about before you go. So now, I don't know if any of you have heard of the dark web. In fact, that is a very dangerous area to go. I'm sure along the line, or possibly when you get to third year, maybe we will talk about that. This place is very dangerous. In fact, the internet that you see, we are only using about a tenth of the internet itself. If the internet is up to here, we are just using this. The one that we normally use is just here. The one that is deep within, we don't really use it. And that is where the hackers normally go there and do certain things, where you steal people's credit cards, there's murder going on. Yeah, in fact, there are so many criminal activities going on in there. And there, of course, there are other things too that goes in there. Somebody can contract someone to probably go and, kill somebody or do something. And all these things can be done in the dark web. And you just don't go to the dark web. There are things that you need to do to go to the dark web. There are special browsers that you need to use to access the dark web address. And the addresses that comes with the dark web, you don't see it as www.uma.edu.gh. You rather see it as gibberish, like A, B, C, 4, 5, 6, 7, 4, 3, 2, .onion. It always ends with what we call .onion. And if you don't know the address, you can't go there. And anybody who is security conscious and want to, and already is there, should always make sure he protects himself. So always get an antivirus. It's about 100 Ghana cedis. It's a good thing if you have one on your computer. And anytime you visit some sites, you have always careful and make sure you don't find yourself a victim when you go to certain websites, especially those pornographic sites, those, in fact, there are a lot of, there are mainly, the main sites are pornography sites and places where you download movies. If you use your phone to do that, be careful. By the time you realize your camera is on and you have no idea your camera is even on, and people are just looking at you and smiling. So be careful wherever you go when you are online. So that brings us to the end of lecture 1. These are some security things that you should keep in mind. By turning off your GPS when it's not in use, these are some few things that you should always have in mind. And these are web languages that we'll be delving in. And